This is lesson 4-8 for Secondary 1 Math. Okay, for the lesson, we're going to be writing some equations to represent the scenario, and then we're going to use our graphing calculator to make the graphs, and then we're going to look at, well, what if we change something about it? How does that affect the graph? So have your graphing calculator ready. You can have your card out that tells you what to do with your graphing calculator if you need to. And so number 1, it says a certain bacteria doubles every hour, and a sample has 6 bacteria to begin with. So I know that my initial value is 6. So when I go to write my equation, I'm going to write y is equal to 6. Since it's doubling, I'm going to write times 2 to the x power. And you don't have to use the parentheses, you can just use a dot, but I'm going to use the parentheses. So the next thing we see down below is the table. And let me just explain how we've got this table set up. This first equation, we're going to fill in our table right there. And then down below, we're going to have some other equations, and we're going to put them in there and there. So that's what this is. It's just to save space so we don't have to write 3 new tables, and we're going to put the graphs on one so we can kind of see the comparisons if we change numbers. So if you haven't already filled in your table while I've been talking, then go ahead and pause the video. And what you're going to do is you're going to use your graphing calculator, and you're going to make a table of values. So following the directions on your card, you're going to make a table of values for this equation. And so you can pause this while you do that. Okay, so when you go to fill in your table, here's what you should have. And then I've put the points on the graph, and then don't forget that we need to label. And so this is going to be the hours on our x-axis, and our y-axis is going to be the number of bacteria. And then since we're graphing the equation, we're going to connect the points. And with this one, we've got to kind of know where our asymptote is. Does it go like that, or does it maybe come down some more? So we have to kind of have an idea. So what you can do is on your graphing calculator, if you use your up arrow, you can see what comes before, like what is up above that in your graphing calculator, and see what's the lowest point that this goes to. And you see that it's approaching 0. So we are going to connect the points like this. So that was important to know, that it was approaching 0 and not approaching like 5, because if we were to write our asymptote, we would have to know what it's approaching. Okay, that's the first one. Now the next thing we're going to do is we're going to change the situation. And so on number 3, it says write a new equation, but this time the bacteria will be tripling every hour. So I'm going to write a new equation. I'm going to color code this, and I'm going to do a different color. So if you have a different color, that's a good idea for this. So y is equal to, and then we're still starting with 6 bacteria, but this time instead of doubling, we're going to be tripling. And so number 4, it says with a different color graph the new equation. So what we're going to do is in this column now, we're going to fill that in. So what you do, go back to your graphing calculator, and in your y equals menu, you're going to change that 2 to a 3, and then go back and find your table, and then you'll be able to fill in your new table. So pause the video and go in and make your new table, fill it in, and then we'll start again. Okay, so we are going to have 6 that we're starting out with, but we're tripling this time. So we're going to go to 18, and then 54, and then 162, and then 486, and 1458. And so you can see that that's getting really big a lot faster. We're still starting at the same point, but it's just going to be going up faster. So the rate of change is increasing. And we're not going to have as much to graph here because it goes off the graph so much more quickly. In fact, we're off the graph after just the first couple. Now going to find the asymptote on that one, you'll find that that one also is approaching 0. So this one's coming down just like this one is. Okay, for number 5, it asks the question, how did changing the rate from doubling to tripling change the graph? So if we look at how the green changed to the purple, as I was saying, it rises faster. It's going up. The rate of change is faster. We're not going to use the word steep because we don't use that with nonlinear equations, but we're going to say that the rate of change was faster. or rate of change was higher, or you can say that it increased faster. And that's how changing that number changes the graph. Okay, for number 6, I'm going to be doing a different color, so I'll do red this time. Write a new equation, but this time the bacteria is back to doubling every hour, but we're only going to have 2 to begin with. So if you want to think about it for a second, how is that going to change my graph? If we're doubling, so that's like what we did in the green, but this time we're only starting at 2 instead of 6. Do you have an idea of what that's going to do to your graph? So what you're going to do is we're going to write our equation. Y is equal to, we're starting with 2 bacteria and we're doubling. And so that's my equation. So now you're going to fill in this part of your table. So pause the video and use your calculator to get your numbers. So you should have gotten 2, 4, 8, 16, 32, and 64. And so this one's kind of an interesting situation because you look at that and you think, oh, well, that's not getting as big as fast. It actually is rising at exactly the same rate as the green one. So if these were lines, they would be parallel because their rate of change is exactly the same. It's kind of like if you and I were both starting a savings account and we were doing it at the same bank, and you had $10 and I had $100, even if we both got the same interest rate, I would always have more than you because I started with more. Not because, you know, my bank account is better. It's just because if I'm starting with more, then I'm going to always have more. It's just kind of a head start. So that's what's going on with the green. It's always going to be higher because it started higher, not because it's growing faster. So what it's doing, in the question for number 8, it says, how did changing the initial value from 6 to 2 change the graph? So as we've learned before, when we change our initial value, or like with lines, it was our y-intercept, it actually is just dropping our graph. So this green, everything is just moving down like that. And so it's just dropping down, and if it wasn't, you know, starting at the same place, they would be exactly the same graph if they weren't starting in a different place. So we're going to say it starts lower, but we are going to say that the rate of change is the same because we want to point out that they are growing at the same rate. Okay, let's go to the next one. Okay, the next one, we're going to go back to compounded interest. And so if you remember, we did this back a while ago, and this is the compound interest formula. And so just to review, P is the initial value, R is your interest rate, N is how many times the interest is compounded in a year, and T is how many years. So remember that you put the N, the number of times it's compounded, in 2 different places. So remember that as we go forward. So number 9, it says an investment of $500 is compounded monthly. And so how many months are in a year? It's 12. And so we're going to have a rate of 3%. So remember, you change that to a decimal point, 0.03. Now it says write an equation to represent the scenario. So we're going to have A is equal to, the principal is how much we start with. And then we're going to have 1 plus, and then 0.03 divided by 12, because that's our R divided by N. And then to the nt power, so 12t is our exponent. Now when you put this in your calculator, you're going to go to your y equals menu, and you need to type it in exactly like this. You're going to type in 500 parentheses 1 plus 0.03 divided by 12, close your parentheses, to the power of, and then remember when there's stuff going on in the exponents, put parentheses around it. So to the power of, and then 12 times x. And I know that we're using t, but the calculator doesn't care what letter you're using. It's the input variable. So that's what you're going to type in your y equals menu. So make sure you've typed it in like that with all the right parentheses and everything, or else this is not going to work. So once you type that into your calculator, we need to do our table set. So remember how to do that. So the table set, and that's above, that's a second and then window key. And the reason why we need to do something there is because our table, we want to make it start at 0 but go by 5s. So it's going to go like from 5 to 10 to 15 to 20 and so on, not 1, 2, 3, 4, 5. So we have to tell it that. So pause the video and have your calculator make the table for you. We're going to put the numbers for this equation in this column, and then come back and we'll graph that. Don't forget to label your X and Y axis. Okay, when you put this in your calculator, we are starting with 500, so that should be the first thing that you're going to get. I'm going to round these numbers to the nearest dollar because, again, with graphing, it's not going to be able to, you're not going to be able to tell the nearest cents anyway. And so when we use a table, it's just a tool. So what you should have gotten is $580.81. So that's going to be $581 when I round that. And then the next one is going to be $674.68. So I'm going to say $675. So if you're not getting those numbers on your table, then you're doing something wrong. It's either when you're entering your equation into your calculator, so go and double check that, or it might be that maybe your table is not going 0 to 5 to 10 to 15. Maybe you're getting like 1, 2, 3, 4, 5 and you didn't change that. So if there's something else wrong, then you need to go back and look at every single step on your card of what to do on your calculator. I'm going to go ahead and fill in the rest of the numbers. So there's the rest of my table. My x-axis is going to be labeled time. In this case, it's my t-axis actually. And my y-axis is going to be the amount in dollars. And then I'm going to graph these numbers. So I'm starting at 500 and going to 581. So you're going to have to, obviously approximate what that is looking like on your graph. So once you've got all your points in there, we need to remember when we connect the dots that this is exponential. So because of our viewing window, it may look a little linear, but we do know that it's exponential. And so it is coming up like this. Now, if you start an account with $500, you probably had less than that at one time, but you didn't have less than that in the account. So it actually is just going to start right there. That will be our beginning. So the next thing we're going to do, just like we did on the previous problems, we're going to go back and we are going to now change the situation. So on number 11, it says write a new equation, but this time we're going to start with $700 instead of $500. So our new equation is just going to change the 500 to the 700, but everything else stays the same. So write down that equation. It's still the same equation. When you go and put it in your calculator, you should be able to go back to what you put in your calculator in the y equals menu right there. And you should just be able to replace the 500 with a 700. Everything else should be the same. You also shouldn't have to change your table. And so you can go up and look at your new table now and you should be able to get those numbers. And so what you should have is, you're going to start with 700 right there. And so I'll give you a minute to do those calculations on your calculator and fill in that part of your table. So pause the video so you can have that time. Okay, rounding to the nearest dollar, we're going to have $8.13 for 5 years, $9.45 for 10 years, $10.97 for 15 years, $12.75 for 20 years, $14.81 for 25 years, $17.20 rounded to the nearest dollar for 30 years. And then for 35 years, we're going to have $19.98. And then for 40 years, we will be at $2,321. And so put those points on your graph. And so you know that we're going to be starting higher at 700 this time. So the account is growing at the same rate. It's just that we're starting with more money. So this is kind of like the scenario I was telling you before, where if you and I were both going to start this account, and let's say you had 700 and I had 500, you would always have more than me because you just started with more. It's not because your account is growing faster or anything like that. It's just that you had a head start. Kind of like running a race. If you have a head start, you're going to be ahead if you're both running at the same rate. Okay, so putting those points on the graph, we don't really have to graph as many because we've run out of space pretty quickly. And so remember that this is exponential, so we're not going to be using a straight edge here. But that'll keep growing over time if you leave it in that account for longer. So then the next question, number 13, it says how did changing the initial value from 500 to 700 change the graph? And so the only thing that changed was it started higher. I'm going to say it started 200 higher, or you can say it started at 700 instead of 500. But the big idea is that it moved up So everything is going higher. It's going to be higher, and it's not going to be like the same, 200 for each thing. It's because of that compounded interest and the exponential nature of it. So this is more than 200 right there. And so that's how that works. So it's not that they're going to be the same distance apart, but the rate is the same. Okay, for the last one on this page, I'm going to change colors again, and this time I'm going to go to number 14, and it says write a new equation where the interest rate is 1%. So we're changing from 3% to 1%, and we're going back to our initial value of $500. So we're going to start with $500 again. But this time, instead of the 3%, we're going to only have 1%. It's still, everything else is still the same, so compounded monthly and all that. So if you go back up to your calculator, your y equals menu, you should be able to just go in and change some things. So this time I'm going to change back to a 500 right there, but I also need to change the 0.03 to a 0.01. And so what you should type in your calculator, let me just write this down for you here. So you're going to write y is equal to 500, and then 1 plus 0.01 divided by 12, close your parentheses to the power of parentheses 12, and then x. And that's how you need to put it in your calculator. If you do not put all those parentheses in there, you are going to have the wrong answer, and that's not going to work for you. So I'll give you a minute, pause the video, and you can go back and find the numbers that are going to go in your table right there. Okay, so the numbers that we're getting, we're going to start with 500, and then it's going to be 526. And so you can see right now, if you compare the red and the purple that I've got there, you can see already what a difference of 1% and 3% is going to make. So already in just the first 5 years, 3% gives us an extra $60 or so. And so that difference is going to become more pronounced as time goes on. So the interest rate is going to be a big effect here. So this next one is going to be 553. And then you should get 581. You want to make sure that you're doing this right on your calculator, because on your test you're going to have to be doing all these numbers on your calculator. And so if right now, if you're depending on me writing it down because you can't find that on your calculator, then that's going to prove to be a problem for you as you do your test and quizzes. So 35 years is going to give us 709, and then 40 years will be 746. And so going to graph that, we're starting at 500 again, but it's not growing as fast. So you can see that this is really taking its time compared to the other ones that we've done, taking quite a bit longer to increase. That almost looks linear. It's not. We know it's not, but it almost looks like it could be because it's so slow growing. So that's what's going to happen there. So as we answer the next question, how did changing the rate of decay, or sorry, that shouldn't say decay. How did changing the rate of growth from 3% to 1% change the graph? I think what we meant is it's going down from 3% to 1%, but it's still growing. So we're just going to say it slows the growth. Or you can say that it's increasing. It still is increasing, but it's increasing much slower. And so just understanding what changing a number does to your equation and your graph and what that means, that's the big idea here. Okay, for this last page, we're going to be talking about exponential decay, and just a reminder of what that is. So instead of doing 1 plus a rate, we're doing 1 minus a rate, and the A is still the initial value. So number 17, a stock is declining, so that's our clue that this is decay at a rate of 25%. So our rate is going to be 0.25 every week. The stock is starting at 220, so that's our initial value. And so writing an equation, it's going to be y is equal to our initial value is what we start with. Then we're going to do 1 minus because it's decreasing or it's decay, 0.25, and then to the x or the t power. And so that's our equation. And so again, let's label our x and y axis. And so these are the number of weeks on your x-axis. And this is our dollar value of our stock. And so pause the video. You need to go to your graphing calculator and you need to input this in your y equals menu. you're going to want to change your table so that you go, instead of 0, 5, 10 like we did in the last one, you want to go back to 0, 1, 2, 3, so your delta table will be 1. And you're going to fill in those numbers. So pause the video and you can do that. Some of you might wonder if it's okay if instead of 1 minus 0.25, if you put 0.75, and yes, that's definitely okay. It's the same thing. So if you want to do it that way, then that's fine. Okay, what you should have gotten on your table, and we're rounding this to the nearest dollar in value, so we're starting with 220, and then we're going to be going down, remember, because this is decay, so 165 is next, and then we're going to be at 124, and so you're just going to copy down these numbers, and you should be getting these same numbers on your calculator. So I am rounding to the nearest dollar, but if you're not getting these numbers, then you need to go back and look at how you entered everything in your calculator. Did you put everything in just right? All it takes is one decimal being off place, or one parenthesis not there, or something. It doesn't take a lot to mess this up. So here are my numbers. And I'm going to go and graph this, and so I'm going to be starting high and going down because it's decay. So I'm starting at 220, then I'll be going down, and it's going to be going down pretty fast because that's what exponentials do. So you're just going to go and graph these. And then as you get towards, down below, it starts slowing down how fast it's decreasing, because you're going to come down to next to nothing, but it's never actually going to get to 0. And that's, we know, because our asymptote. So we're going to connect the dots because we are graphing our equation. And so this is exponential decay. And so that's how that graph is going to look. Okay, go down to the next problem. It says write a new equation where this time we're going to start at 180 instead of 220. So our new equation, instead of 220, we're going to write 180. We're still going to decrease by 25% and to the t power. So you're going to go into your graphing calculator, and in your y equals menu, you're going to change the 220 to a 180. You should not have to change anything else. And then go ahead and put your numbers in this column right there. So as you put these numbers in your table, you notice that we are starting with less money. So even though you would still be losing money, and you're still losing, 25%, but 25% of 180 isn't as much as 25% of 220. So as far as the number of dollars you're losing, it's not as many, but it's still the same percent. It's still the same rate. And so just understanding that the rate is still the same, we're just starting lower. It's just we're starting with less money, so we're not losing as many dollars, but we're still losing the same rate. Now, as these two end up towards the end of the graph, they get closer and closer together, and they are both approaching 0. So that's the thing that we have to understand, is that they're both getting down there, and so they start at different points, but they both kind of converge at the end because they're both approaching 0, and they're both going to get there. The red one will get there faster just because it was closer to begin with. So when we answer question number 21, how did changing 220 to 180, it just started lower. It started with less. Okay, the last one, we're going to go purple. I'm going to go purple this time. So we're going to write a new equation, but this time the rate of decay is 10%. So instead of losing 25%, we're only going to lose 10%. We're going to go back to having 220 to begin with. So again, we're starting with 220. And this time, instead of the 25%, we're going to lose 10%. So if you wanted to, you could do 1 minus 0.10 is 0.9. So 1 minus 0.10, if you wanted to, you could put 0.9 instead of that. Sometimes it's just easier to do it this way, though, because then if you had to change the numbers, you can just go back and change the 0.10 to something else. So pause the video and go and put that in your graphing calculator and make your new numbers and put them in this column right there. As you put these numbers in your table, if you compare the green with the purple right there, you'll notice that even though you're starting with the same amount, you can really tell the difference of losing 25% versus losing 10%. Losing 10%, that wouldn't be nearly as many dollars that you're losing because it's only 10%. So we're still going to be starting at the same place at 220, but it's not going to be dropping quite as fast. So we're going to still be at 198 right there. So it kind of slows it down a little bit. And so if you're losing money, that's a better scenario than if you're losing it at 25%. That would hurt a lot more. So it's going to take more time for this to get down to zero. Eventually it will, but it's going to take a lot more time for that to happen. And so we're actually not going to see it get very close on this graph because we just don't have enough graph to look at. So this is where that's going, and so we're going to graph that, and we can see that it's a lot slower getting down there. It's still going to get down there, but it's going to take a lot longer, relatively speaking. So how did changing from 25% to 10%, it slows the decay, or you can say it's decaying slower, or it's decreasing slower, but something about slowing. And so that's how you're going to do that. Okay, if there's anything that you didn't understand here, you might want to go back to how to enter these things into your graphing calculator, and go back to your card and make sure you're following the directions, or come get help from your teacher. And if you have any other questions, please see your teacher.